Hi y'all, my name is David Day and I'm going to go over basically a brief tutorial on how relational databases work. And so to do this, I first want to show you what relational databases solve. So as you can see in this first example, I wanted to use it sort of like a forum website where you have a bunch of these little forums and users can go and post content and whatever it may be. Maybe a programming forum where they post little code snippets or maybe need help with their programming. And as you can see at the very top of the pyramid, we have a user. And a user, I put it at the top because the top has the smallest little triangle. And so it has the least amount of privileges that the person can do on the website. In this case, a user may only be able to post content or update their settings, but that's it. They can't really do anything more than that. But as you walk your way down the pyramid, you see it starts to get larger and larger. And so, for example, the forum moderator has more privileges than a user does, and that's basically to say that a forum moderator can do anything that a user can, but a user can't do anything that, or everything that a forum moderator can. And you just work your way on down after each example. So the user has more than the forum moderator has less than the website, but then ultimately you have the admin who has ultimate control over everything. The next thing that relational databases solve is duplicate data. So we're going to kind of go over some different examples such as addresses, titles and descriptions, and then as well as products. So let's go over the first, the hierarchical. That's this pyramid here. And I created a little simple database and basically has 4 fields. It's probably not usable for anything, but for the sake of simplicity, I created this, and it has your auto-incrementing ID field, which is unique. You also have the email field, which is also unique. Then you have your password, which is, I set it up as medium text, which could basically store a hash value. That's ideally what you would do. And then you have the title. Going back to our little pyramid, the title would represent user, forum moderator, etc. And here's some sample data. So you see this number auto increments every row. You have some sample data in here. So I don't know if these email addresses are real or not. I want to try to use them, but it has their email, the hash password, and then their title on top of that. And so I want to kind of go over some of the pros and cons of this simple database. Pro is that it's super simple to build. I mean, it took me like 5 seconds to build that thing. Everything is in one place, and because of this, it's very easy for humans to read. So if I were to take over this sample forum website and I go into the database and I see this data here, it's very easy for me to read, okay, mbolin0@ning.com is an admin, or this email here is the website moderator. It's very easy for me to read it because it is all in one place. However, there are some cons. For example, it's very difficult to validate the input. What if, let's say for example, some websites use the title super moderator instead of website moderator, and you try to insert a row that has super moderator instead of the website moderator, which is what we want it to be defined as here. Well, it's very difficult to validate that because you would basically be able to insert anything. What a relational database will do is it'll validate, we'll go into details later, but it'll validate that the row that we are inserting points to a valid title. And then finally, the last thing is that variable length strings take up quite a bit of memory. And what I mean by that is that these titles here, these are defined as, in this case, a varchar 15. And essentially, I'm not going to go into the nitty-gritty of it, but anytime you're working with strings, especially in languages where strings are immutable, it can be much more complex to work with those as opposed to numbers, which is what a relational database does. So those are the pros and cons of this little simple database. Let's go over how a relational database would look. So in this case, we have the same first 3 fields. We have the username, email, and password. But in this case, we have this title field here, this title ID field. And what this does is it acts as a foreign key, which is a keyword. It acts as a foreign key to link to this table here, this titles table. And what this titles table does is it has its own auto incrementing ID field here. And then on top of that, it has the actual title such as admin, user, etc. So here is how the first table would look under relational database model. So you can see I have, instead of admin, website moderator, super moderator, user, and user, now I have 1, 2, 3, 4, 4. And what this does is it links to this table here, which we only have 4 rows now. And now this then links to those particular fields. So whenever I look at efreebury4 at desdev.cn, I see that their title ID is 4. I'm going to look at this titles table here, and I'm going to say, okay, which one is number 4? Oh, okay, that's the user. And that's how we essentially validate the data, because if we were trying to insert a row in here, we're not going to insert it with admin, super moderator, forum moderator, user anymore. We're going to insert it with the number. And what we can then do is check if the number that's being inserted here links up to one of the auto-incrementing title ID fields under this title table now. Another thing that this does is that it's much simpler to work with the data. So in the prior table, let me pull that back up for you here. I had said how it's much more difficult for programming languages to compare strings than it is numbers. So in this case, it was comparing varchars. In this case, what we're going to do, let's say that we have a user, or a more common example. You have a bunch of these different forums, and a forum moderator can only moderate whatever particular forum they're assigned to. And they tried to moderate a forum that they're actually not assigned to. What your developing language would then do is compare, okay, does the title ID, or in this case this access level, since number 1 is the greatest and number 4 is the least amount of privileges, it will say, okay, does this forum moderator title, is it less than or equal to whatever forum it's particularly matching? So you can see it's much easier for those languages to compare numbers than would be for it to say, okay, is this person a super moderator, and does this person also have access to this particular forum? It's much easier for that underlying language to compare numbers instead. So let's kind of move on to the duplicates, and for this simple database, I have a person table. And within this person table, what I'm going to show is how we actually you almost used the keyword there, normalize, but how we set up the database in a relational database model for particularly the address. And so what we've done here in the simple database is we have the first name, last name, street, which would be 123 Main, the city, state, and zip. And then of course you have your auto incrementing ID field here. So here's some sample data. Again, I just put in some, I actually believe New York has the zip code 1000, but I have no idea about California. I have no idea about that. But as you can see here, all of the data is in the same place, and so really when it comes down to pros and cons, it's the same thing as the hierarchical sample. The pros is the same exact thing. It's easy to build, everything's in one place, and it's easy for a human to read. The cons, again, it takes up a lot of memory whenever you use those variable length fields. In this case, we have 1, 2, so 2 of these that we'll be fixing are variable length, and then these 2 here are fixed length fields, but still, fixed lengths are still difficult to compare, not so much as a variable length, but it's still easier to compare numbers in most instances. And then of course, duplicates take up a lot of unnecessary memory. Let's go back to this example here, and let's say for example that we had 100 rows in this table, and all of them shared the same state, or most of them shared the same state. I mean, that's taken up a lot of unnecessary memory, having, in this case, NY repeated over and over. Or even worse, let's say the city, because, cities take up a much longer field than the state field, and you have 50 rows where they share the same city. Why would you need that? You really don't. And so the relational database solves this issue. So let's go into how a relational database model would look. And because it was so much, I had to split it between two slides. But you see here, I have my person table like I had before, and it still has the first 4 columns the same. You could, in theory, normalize, which is what I'm going to go over here in just a second, the street column. But in this instance, I didn't. And I'm going to kind of go over why in just a second. But as you can see now, I have the city ID, which is a foreign key that links to the city's table. And in this case, the cities just have the auto-incrementing ID and then the city name. The state, however, has some additional info. So the state ID field here links to the state's table. And before in our simple database, all we cared about was the abbreviation. Well, because we have a relational database model now, we can actually store some more information. So we can actually store the actual state name as well as the abbreviation. If there was more data, we can store it in here, and it all organizes the data pretty, in a pretty efficient manner. And then finally, you got the zip, which leads to the zip code. And in this example, I used it to mimic exactly how the cities is. It's just the auto-incrementing ID field and then the postal code field. But I will show you how you can actually extend this in our sample data. So here's the sample data of the relational database, and you can see these first 4 here, they don't change. But now we're using numbers for the address. So the city points to 1 or 2, and you can see 1 is this town and 2 is that town, and that's really all that there is. There is quite a bit of cities in the continental US, so I don't know if you would want to pre-populate all of the data with every single city. You may just want to build that data as you go. However, as you can tell under the states, I have it as 35 for New York and then 5 for California. And the reason for that is because since there's only 51 states in the US, they're 51 or 50. I don't know. I did terrible in history. But because there's only so many states within the continental US, what I went ahead and did was just preload all of the data in this table, and I won't have to build it as I go. It's already stored there. And in this case, 35 points to New York and 5 points to California. And then finally, the zip ID. Again, you may want to pre-populate this data. You may want to build it as you go. That's really entirely up to you. For the sake of this example, I just demonstrated as if we're building it as we go. But you can see in the sample, I added this this suffix column here. So the auto incrementing field is the same, and the postal code, we're building that. However, in this example here, you see I only included the postal code, but what I'm trying to show you is that you can add more data. In this case, we added the suffix, so the 10000 dash 1234. I don't know if that's proper suffix or not. It probably isn't. But you can add additional data whenever you create a relational database, and that really helps the data stay organized, and it really keeps it in a more efficient manner. So I've kind of floated this keyword around quite a bit, and it's called normalization, or normalize. And essentially what that is we restructure the database in such a way as to organize the data to conform to the relational database model. And some of the benefits of normalizing databases are you get improved performance on your statements, so your insert, update, delete, and order by statements. Not only that, but there are fewer null values. You really don't want to have that many null values in your database. I don't know, perhaps you may design your database to include a bunch, but if you can try to limit the number of null values that you have, that's always beneficial. And then not only that, there's less opportunity for inconsistencies. So like I mentioned back in that hierarchical style, and I need to change the slide name. I have hierarchical here. That should show duplicates. But anyways, if I go back to this hierarchical here, you can see that the example that I used with there's no valid way to validate the titles or there is, but it's much more difficult. Whenever we normalize the data, there is less opportunities for inconsistency. So we won't have that super moderator title versus the website moderator, which is what it's supposed to be. So the yin and yang of normalization. So warning. As the number of normalized data increases, so does the complexity of the join statements used to retrieve that data. So too many complex join statements can start to hinder the performance of the query, which in turn defeats the purpose of a relational database in the first place. So you really have to have that balance and between over-normalization and achieving a well-defined relational database. Well, that's pretty much it. I hope you learned something today. If not, put in the comments. I'm always looking for suggestions. And hopefully within one of these next tutorials, I'll show you how to perform some of these join statements to get the data that you normalize. But that's everything. I hope that you enjoyed it. Leave comments below, subscribe, do that whole shindig. All right, thank you so much. Bye-bye.